Here is an example involving the sums and products of zeros of a quadratic polynomial. Let p of x equal 2x squared plus 3x plus 7 with zeros x equals alpha and x equals beta. Find A, alpha plus beta, B, alpha beta, C, 1 on alpha plus 1 on beta, and D, alpha squared plus beta squared. So for part A, alpha plus beta, that's the sum of the roots, and that's equal to negative b on A. So negative b, so negative of positive 3 over 2, so that's just negative 3 over 2. B, alpha beta, so that's the product of the roots, and that's equal to c over A, so that's 7 over 2. Now C, 1 on alpha plus 1 on beta, we need to rearrange this fraction or somehow work with this fraction so that we end up with expressions involving alpha plus beta and alpha beta, because those we do know the value of. So what we're going to do is express the sum of these fractions as a single fraction by multiplying the 1 on alpha by beta on beta and 1 on beta by alpha on alpha. So we end up combining these two fractions and it becomes beta plus alpha or alpha plus beta over alpha beta. Now alpha plus beta we know the value of, that's negative 3 on 2, and alpha beta is 7 on 2, and dividing those two fractions together we end up with negative 3 over 7. And lastly, part D, alpha squared plus beta squared. Now again, just looking at it just on face value, we can't work that out. However, we do know that there is an expression that is almost equivalent to that, which is alpha plus beta all squared, because that will give us the alpha squared and the beta squared term, and alpha plus beta we know the value of, which is negative 3 over 2. So if you expand alpha plus beta all squared, that's alpha squared plus 2 alpha beta plus beta squared. So we're actually this value is too big or too large by 2 alpha beta, so we need to subtract from that 2 alpha beta to end up with an expression equivalent to alpha squared plus beta squared. So alpha squared plus beta squared is equal to alpha plus beta all squared, and that creates a 2 alpha beta term which we need to subtract out here. However, we do know the value of alpha plus beta, so that's negative 3 on 2, and we square that, minus 2 times the product of the roots, alpha beta, and we know that that's 7 over 2, and that evaluates to negative 19 on 4.